Now we are going to solve question number 4 for Pure Mathematics 1, January 2021. So let's begin with the question. The question is, the points P and Q as shown in the figure have coordinates -2, 13 and 4, -5 respectively. It means the first one, this coordinate is P and this coordinate is Q. A straight line L passes through P and Q. Find an equation of L, writing your answer in the form y is equal to mx plus c, where m and c are integers to be found. The first part is very simple. We know that we have, if we need to find, let's say, if we need to find the equation of a line, we need y-intercept, because in this form we need to find the y-intercept and gradient. So first, I have 2 points, so I can easily find the gradient. Gradient will be in this case and will be equal to, if I take this as x1 y1 and this one x2 y2, so gradient will be y2 minus y1 over x2 minus x1. So I can write it -5 minus 13 over 4 minus -2. So that is going to be -18 over 6, which is -3. So if in general I consider this equation y is equal to mx plus c, and replacing the value of m in this one, y will be equal to -3x plus c. Now to find y-intercept, I can use any one of these points in this equation. So let's suppose I'm going to put this point. So if I put y is equal to 13 and x is equal to -2, it will be -3 into -2 plus c. So 13 equals 6 plus c. So c will be equal to 13 minus 6, which is finally equal to 7. So then equation will become in this form. If I will write the value of c in this one, so y will be equal to -3x plus 7. So that will be equation of line y is equal to -3x plus 7. It's pretty easy question. Part B is, the quadratic curve C passes through P and has a minimum point at Q. Find an equation for C. Now we know that if we have a minimum point, this Q is taken as the minimum point of the curve, and if the minimum point, and looking at this one clearly, it's a quadratic equation. If in the quadratic equation we have a minimum point, let's suppose if I have a quadratic equation whose minimum point is PQ, so then we can write it in this way: y is equal to a into x minus p plus q. So if I consider this PQ as q is the minimum point, so it means my this minimum point 4 minus 5. So p is equal to 4 and q is equal to -5. So then it will take, sorry, it should be square also. So then it will take this form: a into x minus 4 minus 5, minus 4 square minus 5. So now to get the value of a, I can use the second point, as second point is also lying, you can see point P is also on Q, so, on this curve C. So I can put this point P, which is which is -2, 13. So if I put P, point P, which is -2, 13. So I will get y is equal to, in this one, this is x. If I take this x and this one as y, so I can get the value of a also. So y will be equal to, in that case, y is going to be the value of y I have to take 13 and the value of x as -2. So it will become 13 equals to a into -2 minus 4 square minus 5. So that will be 13 equals to a into, this will be 36 minus 5. So 13 plus 5 is equal to a into 36. So a will become 18 over 36, which is 1 over 2. So it means the value of a, if I replace here, so y will become, the equation of the curve will be 1 over 2 x minus 4 square minus 5. So that is equation of curve here. Now part C is, the region R shown shaded in the figure lies in the second quadrant and is bounded by C and L only. Use the inequalities to define the region R. Now, if we look at this one, we can see uh, this region R. This region R is above the line and below the curve. So if it is above the line, this is equation of line. It means I can say in this case it is above the line. So being above the line, this is equation of line we are having. So I can write it mean and it is solid line also. So the inequality in that case will be y will be greater equal to, because it is greater than, it's above this one, so y will be greater equal to minus 3x plus 7. Being the solid line, I have to write this greater equal to. Now for the second one, it's under the curve. So if it is under the curve, so it will be y less equal to, because the curve is also solid curve, it will be less equal to this equation of curve I can write here, which is 1 over 2 into x minus 4 square minus 5. So will be 1 over 2 into x minus 4 square minus 5. But we can see also, if this is the region, there is another region which is above the line and under the curve, that is this region. So to make it clear, so this region should not include it, because we only have to consider this region R here. So for that one, if I will say the coordinate of the point PR, if I will look at the coordinate of the point P, that are minus 2, 13. So x coordinate is minus 2. It means the solution region is on this side. So I can also write x should be less equal to minus 2. So now these are the three inequalities that will satisfy the solution region.